Hello, students. In the previous chapters, we had covered coplanar forces, centroid, and friction chapter. In coplanar force system, lines of action of all the forces lie in one plane, whereas in space force system, lines of action of all the forces do not lie in one plane. Right. Well, you can have a look at the diagram, what has been shown on the extreme left side. On this diagram, this is a cube on which number of forces have been applied. With on the cube defines six faces or six planes. You can see that few forces may lie in one plane, but all the forces do not lie in one plane. Let's take the example of top face. On the top face, it is that this 10 kilonewton will lie in the top face in the plane defined by a top face, and this force will lie. Whereas if you take the front face, this face, on which you'll see that 10 kilonewton will lie, 6 kilonewton will lie, this 6 kilonewton will lie, 20 kilonewton will lie. But all the forces will not lie in any of the six planes defined by this cube. Such a force system is called as space force system. So students, in this chapter, we are going to deal with space force system. Space force system will also be of three types, that is concurrent force system, parallel force system, and general force system, as we had three types of the problems in resultant of coplanar force system as well as equilibrium of coplanar force system. For space force system, as per MU syllabus, you have only resultant problems and the problems of the basic concepts related to space force system. We need to learn the knowledge, we need to learn or revise the basic concepts of vectors from our previous knowledge before we start solving the sums. So let's revise how to find the force in vector form when magnitude and direction angles are given. So look at this diagram. You define it. This is your x-axis, this is your y-axis, and this is your z-axis. You have a force F which is making angle theta x, theta y, theta z with x, y, and z axis. We are assuming that Fx, Fy, and Fz are the three components of this force along x, y, and z direction. If so, then we can understand that Fx will be equal to F cos theta x, Fy will be F cos theta y, Fz will be F cos theta z. We need to remember, understand that in case of the space force system, we have cos components only, not like in coplanar forces, adjacent is cos, other is sine. Here, all are adjacent only. Here, right, force F is making angle theta x with x-axis, theta y with y-axis, theta z with z-axis. So all are adjacent angle or are cos components only. So if you have the three components of the force in x, y, and z direction, that is Fx, Fy, Fz, where ijk will be the, suppose ijk are the unit vectors in I, x, y, and z direction, then force F can be written in vectorial form as F bar is equal to Fxi plus Fyj plus Fzj. Ijk are the unit vectors in x, y, and z. Fx, Fy, and Fz are the components of force F in x, y, and z directions. Students, out of the three angles, theta x, theta y, theta z, if two are given, third one can be determined. There is no relation like, if force is making 30 degree with x-axis, it will make 60 degree with y-axis. There is no such relation in space force system. So only the relation what we can use it is if out of the three angles, theta x, theta y, theta z, two are given to you, third one can be determined using this relation. What is that relation? Cos square theta x plus cos square theta y plus cos square theta z is equal to 1. By mistake, it is printed as theta x. It is theta z. I hope you can understand. Cos square theta x plus cos square theta y plus cos square theta z is equal to 1. Also, we understand from here, cos theta x is equal to fx upon f cos theta y is equal to fy upon f, and cos theta z is equal to fz upon f. So that gets you the unit vector in the direction of the force. How do you get the unit vector in the direction of the force? Force vector should be divided by its magnitude. So if I divide by magnitude, so unit vector in the direction of force will be what? Fx upon Fy, Fy upon Fj, and Fz upon Fk. So this is becomes a unit vector. Unit vector is going to be the, and Fx upon F is nothing but cos theta x, Fy upon F is cos theta y, Fz upon F is cos theta. So unit vector in the direction of force is cos theta xi plus cos theta yj plus cos theta zk. So this is what is the unit vector in the direction of force. Now, next, force in the vector form. When magnitude of force and 2 points in the line of action of the force are given to you. Now, x, y, z are the 3 reference axes. You have the force F, magnitude force F. 2 points on the line of action are given. P is the initial point, Q is the terminal point. Suppose P is having the coordinates x1, y1, z1. Q is having coordinate x2, y2, z2. So you want to write force in vectorial form when magnitude and 2 points on line of action are given. So force F bar will be equal to magnitude of the force into unit vector along the force or in the line of action of the force. What is that going to be? Lambda PQ. P is the initial point, Q is the terminal. Lambda PQ will be unit vector along PQ. How will you get unit vector along PQ? Vector PQ divided by mod of PQ. So unit vector along PQ will be first in the numerator vector PQ. PQ means what? Q minus P. So that is x2 minus x1I plus y2 minus y1j plus z2 minus z1k. That is the vector PQ. Divide by mod of PQ. Mod of PQ means what? Square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So that becomes the unit vector along PQ. Okay. Next, we need to understand what is position vector. Position vector of a point P, any point is defined with respect to origin if nothing is given to you. In the given diagram, suppose we have a point P having coordinates x, y, z, and I want to write its position vector to define its position. So position vector, if nothing is given, we will be writing it with respect to origin. So we denoted by r bar. R bar means equal to a vector originating from O. I mean it's and towards P. So r bar is equal to P minus O. That is what is x minus 0I plus y minus 0j plus z minus 0k. All right. Now, how do we find the resultant of the concurrent force system? In the given diagram, I have shown forces F1, F2, F3, and F4. They are passing through point P. That means the forces F1, F2, F3, F4 are in the space, but still they are passing through point P. So I'll call this as concurrent force system in space. What we call it as resultant of concurrent force system in space or space concurrent force system. To find the resultant of space concurrent force system, you need to write each and every force in vectorial form. After you have written each and every force in vectorial form, you have to simply add them up. Simply add them up in vectorial form. So you will get the resultant in vectorial form. Resultant of the concurrent force system will be obtained by adding them in vectorial form. So F1 bar plus F2 bar plus F3 bar plus F4 bar. So that way the resultant is arrived at. So this way what happens, IJK coefficients of all the forces will be added up. So whatever resultant you get it in vectorial form, its I coefficient will be X component of the resultant. J coefficients will be Y component of the resultant. K coefficient will be Z component of the resultant. Then magnitude and direction of the resultant force can be arrived at. Next, we understand component of the vector along the given direction or some other direction. Suppose here you have the two vectors A and B. All right. You all have learned it that A dot B is equal to mod of A mod of B cos theta. Suppose you want to find component of A bar along B bar. So what will be that? That is equal to mod of A cos theta. That means A dot B upon mod of B. Similarly, if you want to find component of B bar along A bar, it is A dot B upon mod of A. So what way you can understand it whenever you are looking for a component of a vector in some other direction? All right. So numerator will remain same, whether it is component of A bar along B bar or it is component of B bar along A bar. Numerator remains same, that is A dot. In the denominator, what will come? The mod of the vector along which component is required. Mod of the vector along which, suppose you are writing here component of A bar along B bar. So numerator is A dot B divided by mod of B bar. Suppose you are looking for component of B bar along A bar. So numerator will be A dot B and divided by denominator will be what? Mod of A. So numerator will be dot product of two vectors and denominator will be mod of the vector along which component is required. So this way you can remember, this is all what you can call it as we have revised the theoretical concept which we needed for solving the problems of this chapter. Now we'll learn few more things which we did not have in coplanar forces. We have it altogether a different concept to solve the problems. Now this article is what is movement of the force about a point. How you are finding the movement of the force about a point in coplanar force system, that has nothing to do in space force system. Now here you have the force F bar F, which is acting along PQ, from P towards Q. You want to find moment of this force about A. So what will be the moment of force about A? You have to find like this. Moment of force about A will be R bar cross F bar. All right. Moment of the force F about point A will be R bar cross. It cannot be F bar cross R bar. So what is that? R bar cross F bar. F bar is what? Force in vectorial form, which we know how to write the force in vectorial. R bar is position vector of any point on the line of action of the force with respect to moment center. What is R bar? Position vector of any point on the line of action of the force with respect to moment center. So here R bar can be position vector of P with respect to A, or it can be position vector of Q with respect to A. All right. Here you have one more term which we do not have in coplanar forces. What is that? Movement of the force about an axis or the line. So here also we can remember the steps like this. You have the force which is acting along PQ. You want to find movement of this force about line AB. Moment of the force F you want to find about line AB. You should remember the steps are like the moment of the force about AB is dot product of unit vector along the line and moment of the force about first point on the line. So if you are looking for moment of the force F about AB, so it is dot product of unit vector along AB, that is AB. So here also AB will come, and moment of the force F about first point on the line. What is first point on the line? A. All right. Then you can further elaborate it. Lambda AB dot here moment of force F bar about A. You can write it R bar cross F bar. In fact, it becomes a box product, but you will never write it as a box product. You'll remember it only this step. You'll remember the moment of the force about any line is equal to dot product of unit vector along the line and moment of the force about first point on the line. So with this, students, we are ready to start with the problems. So initially we'll have some problems which are on the basic concepts of how to write the force in vectorial form, how to find the movement of the force about a point, then about a line. Then we'll come to the problems of resultant of concurrent force system. As you can see, that heading also itself is showing in the same manner. What the heading is showing, it is showing the resultant of concurrent forces, including basic concepts. So initially we will discuss the problems which are based on fundamentals. Let's start. Problem number 1. Guy wire, wire only of a pole is anchored by means of a bolt at point P, as shown in the figure. The force in the wire is 100 kilonewton. He says that force is 100 kilonewton. Now this is the pole. You have the one end of the wire is connected to this pole at point Q, which is lying on y-axis. Another point P, where this guy wire is connected, is in XZ plane. So students, we need to draw the diagram again. What he is asking, component of the force in XYZ direction, that is Fx, Fy, Fz. Also, he is asking directions of the force. Also, assume the force on the bolt P. So we will be considering the, as he has mentioned, force on the bolt P. We draw the diagram showing the wire and the coordinates. This is the tower. I have shown the pole, point Q and point P. So student, we want to write the force in vectorial form. So we need to write the coordinates of point P and Q. Point Q is lying on y-axis, so it will have only y coordinate. Point Q is lying on y-axis, so it will have only y coordinate. Can you see that? It is above the origin by 100 meters. So its coordinates x and any point lying on y-axis will have x and z coordinates 0. So coordinates of this point will be 0, 100, 0. Now we come to point P. Point P is lying in XZ plane, so its y coordinate will be 0. Point P is lying in XZ plane, so its y coordinate will be 0. Now let's write the coordinates of point P. Now you can see that its coordinate parallel to x-axis on positive side is 50. So x coordinate is 50. Y coordinate will be 0 since it's lying in XZ plane, and z coordinate is 40. As it is parallel to z-axis, it is 40 meters away from origin. All right. So what are the coordinates of point P? 50, 0, 40. We have to take the force acting at point P. So we have taken tension in the wire away from P, right? If it has not mentioned that, you could have taken it at Q, away from Q also. We have taken right now, it is away from P, acting at point. Now, magnitude of the force is 100 kilonewton. So you want to write the force in vectorial form. So what will be that? Magnitude 100 into lambda PQ. Lambda PQ means what? It is vector PQ upon mod of PQ. Vector PQ means what? Q minus P. How will you write Q minus P? 0 minus 50 minus 50i. 100 minus 0 plus 100j. 0 minus 40 minus 40k. Divide by its mod, square root of 50 square plus 100 square plus 40 square. And on using calculator, you get F bar as minus 42.11i plus 84.22j minus 33.69k. So the IJK coefficients of this force are components of the force in X, Y, and Z. I coefficient is 42 minus 42.1, that is your Fx. 84.22 is J coefficient, that is your Fy. Minus 33.69 is K coefficient, that is your Fz. Now you want to find the three angles. So what is cos theta x is Fx upon F. Here you have to substitute the value with negative sign only, minus 42.11 upon 100. Using the calculator for cos inverse, you get theta x is equal to 114.9. Similarly, cos theta y is Fy upon F, that is plus 84.22 upon 100, you get theta y. Then cos theta z, Fz upon F, Fz is minus 33.69 upon 100, you get theta z. So this way, he asked the three components of the force. We got it, Fx, Fy, Fz, and he asked the directions of the force. Directions we got theta x, theta y, and theta z. Let's move to the next sum. I read the next sum. A force acts at the origin in the direction defined by angles theta y 65 degree, theta z 40 degree. Knowing that x component of the force is minus 750 newton, that is Fx is given. Determine the other component. That means theta y and theta z are required, and we need magnitude of the force. The value of theta x. As students, theta y and theta z are given to you, you can find theta x using the relation cos square theta x plus cos square theta y plus cos square theta z. Theta x is unknown. Substitute the value of theta y and theta z. Use calculator, you get theta x two values, 61.03 and 118.90. As students, it is given that Fx is minus 750 Newton. The valid value of theta x will be 118.97 because that only will get you the Fx negative. Now, so we understand that cos theta x is equal to Fx upon F. Substitute the value of theta x, substitute the value of Fx, you get the F. So this is the magnitude of the force. Then cos theta y is equal to Fy upon F. Substitute the value of theta y, substitute the value of F, you get the value of F. Similarly, cos theta z is Fz upon F. Substitute the value of theta z, substitute the value of F, you get Fz. Here, you could have found directly also once F is known to you. Fy is F cos theta by Fz is equal to F cos theta z also. So this way also we could have found. Now let's move to the next sum of the fundamentals. Problem number 3. A force of 1200 Newton act along PQ. Coordinates of point P are 4, 5, minus 2 and Q point minus 316 meter. Calculate the movement about the point A 3, 2, 0. Now students, this is a presentation of the force and the moment center. It is not as per the sign convention, or you can say that as per the sign convention of the space force system. So this is a working diagram, we call it. Working diagram means the diagram which helps us in solving the sum. So now we have we have not shown x, y, and z axis. Simply I have drawn a line showing the force F as 1200. I've shown P point with coordinates what is given 4, 5, minus 2. Point Q with coordinates minus 3, 1, and 6. All right. And you want to find moment of the force about the point A. So I have shown it somewhere point A with coordinate 3, 2, 0. So first we know that what is moment of the force about a point? R bar cross F bar. R bar is position vector of any point on the line of action of the force. So first we'll write the force in vectorial form. How do you write this force in vectorial form? This initial point of this on the line of action force is P, and final point is P. I mean, it is acting from P towards Q. So F bar is equal to 1200 into lambda PQ. Lambda QQ is what? Vector PQ divided by its mod. So 1200 into, first we write in the numerator multiplied with what? Vector PQ. PQ means what? Q minus 2. Minus 3 minus 4 minus 7 I. 1 minus 5 minus 4 J. 6 minus minus 2 8K. Divided by square root of, that is mod of PQ. So, square root of 7 square plus 4 square plus 8 square, you get the force in vector form. R bar. R bar is position vector of P with respect to A, or you can take it Q with respect to A. Right now I've taken position vector of P with respect to A. That is P minus A. 4 minus 3, 1 I. 5 minus 2, 3J. Minus 2 minus 0 minus 2 K. Now, moment of the force F about A is R bar cross F bar. So then you'll show IJK. R bar is coefficient are 1, 3, minus 2. Force vector, force coefficients are minus 739.6, minus 432.6, plus 845.2. You solve it and then you get the answer. How do you solve it? Although you know it well, I coefficient. Row and column cancelled. 3 into 845.2 minus 432.6 into minus 2. So that comes out to 1690. Then we take minus J. Outside we write minus J. Row and column are cancelled. 1 into 845.2 minus outside into minus 739.6 into minus 2. You will get J coefficient. Then plus K. Then again 1 into minus 432.6 minus 3 into minus 739.6. So that comes out to be 1796.2. So this way we get the moment of this force F about. This step, the problems finding the moment of the force about a point are asked many times in our examination as the problems based on fundamentals. So I'll discuss one more sum of this time. A force of 100 Newton acts at a point P having coordinates minus 235 meter, has its line of action passing through point Q having coordinate 1034. Calculate the moment of this force about origin. In the previous problem, it was about point A. This time it is about origin. Origin is having coordinates 0, 0. Now again, we have drawn a working diagram. In working diagram, I have shown the force F of 100 Newton. I have shown coordinates of point P minus 2, 3, 5. Coordinates of point Q, I have shown it, so that I can write the force in vector form. We have to find position vector. R bar is position vector any point on the line of action of the force with respect to moment center. So I think we have taken here position R bar is equal to position vector of P with respect to O. So it is P minus O. So whatever the coordinates of point P are there, same will become the position vector, because you are finding them with respect to origin. So what is that? Minus 2 minus 0 minus 2I, 3 minus 0 plus 3J, 5 minus 0 plus 5K. This is your position vector of P with respect to O. Then you need to write the force in vectoral form. Force in vectoral form, F bar is equal to F into lambda PQ. It is 100 is magnitude. Lambda cube PQ means what? PQ upon mod of it. PQ vector, will write it. Q minus P. 10 minus minus 2, 12I. 3 minus 3, 0 J. 4 minus 5 minus 1 K. Divide by mod. Mod is what? Square root of 12 square plus 1 square. So this way you get the force in vectoral form. You already got the position vector of point P with respect to O. Now you can write moment of the force F about O. It will be R bar cross F bar. Again, we'll write it IJK minus 2, 3, 5 coefficients of position vector. And then coefficients of force vector, I mean Fx, Fy, Fz. Fx is 99.65, Fy is 0, and Fz is minus 8. Again, you will use your calculators, right? And you get the answer like this. At the last, when you write the answer, it's always better to write in the bracket units, right? As the force was having force was in Newton and distances were in meter. So movement of the force about O will be, final units will be Newton meter. All right. Quite simple, right? But quite important from the examination point of view. We take one more problem of this type. Problem number 5. The force F bar 80I plus 50J minus 60K passes through a point A. Complete its movement about point B. This time force is directly given to you. You have not to write the force in vector form. Force of which the movement is required, it's already given to you in the vectorial form. So it is relatively simple. F bar is 80I plus 50J minus 60. It passes through point A. Coordinates of movement center are also given to be 8, 1. So what will be R bar is only to be written first. R bar is position vector of any point on the line of action of the force with respect to moment center. So position vector of point A with respect to B. So what is that? A minus B. A minus B means what? A 6 minus 8 minus 2i, 2 minus 1 plus 1j, 6 minus 4 plus 2. All right. You have written position vector, you have written force vector. Moment of the force F about D is equal to R bar cross F bar. Then you write it ijk minus 2, 1, 2, and components of the force 80, 50, and minus 60. Solve it, simplify it, you get the answer minus 160i plus 40j minus 150k. In this problem, no units are given. So in the answer also no units are. All right. Now we are ready for the next problem, which will have more concepts of the topic. I read the problem. A force P1 is equal to 10 Newton in magnitude x along the direction AB, where coordinates of point A and B are given. What are the coordinates of point A? 3, 2, minus 1, and B, 8, 5, respectively. Another force P2 is equal to 5 Newton in magnitude x along BC, where C has coordinates minus 2, 11, minus 5. Determine number 1, the resultant of P1 and P2 in vectoral form. Moment of the resultant about point D, whose coordinates are 1, 1, 1. Magnitude of the component of the resultant along line BK, where coordinates of point K are 5, 8. We draw the diagram. Again, this is a working diagram where we are showing that force P1 is acting from A towards B, or we can take it up and here and other forces acting from B towards C. Here there is a slight mistake. I have taken it, assumed this force, although P1 is acting along the direction AB. So it is arrow is shown it by mistake. It is shown from B to A. Actually, it is from A towards B. In the working, it has been taken correctly. All right. Just while drawing diagram, this is a printing error. This arrow should have been toward A towards B. All right. So coordinates of point A 3, 2, minus 1. Coordinates of point B 8, 5, 3, and coordinates of point C minus 2, 11, minus 5. P2 magnitude is 5 Newton, P1 is 10 Newton. All right, now we write force in vectoral form. P1 is equal bar is equal to 10 into lambda AB. 10 into lambda AB. All right, coordinates of point that, right? Lambda AB will be what? First we write vector AB. AB means B minus A. 8 minus 3, 5i. 5 minus 2 plus 3j. 3 minus minus 1, 4k. Divide by its mod, you get the force P1 in vectoral form. Now we come to force P2 in vectoral form. It is magnitude 5 into lambda BC. Lambda BC means what? Vector BC upon its mod. So 5 into lambda BC means vector BC. BC means C minus B. Minus 2 minus 8 minus 10i. 11 minus 5 6j. Minus 5 minus 3 minus 8k divided by its mod. So you get the force P2 in vectorial form. Now P1 and P2 are concurrent at B. So their resultant will also pass through B. So R bar at B will be equal to P1 bar plus P2 bar. So just add them up, you get the result. What do you get? The resultant. Is it clear? But this resultant is in vectoral form. We read the question for resultant of P1, P2 vectoral form. So I don't need to find magnitude and direction of result. All right, I can leave it as it is because he has asked the resultant in vectoral form only. Now, second part of the sum, he is asking you to find the moment of the resultant about the point D having coordinates 1, 1, 1. So write resultant force is when vector form is ready. R bar is position vector of point B. I cannot take A, I cannot take C because B is the only point on the resultant. So resultant as forces P1 and P2 are passing through point B, resultant will also pass through point B. All right. So R bar will be position vector of point B with respect to B. Coordinates of point B are 8, 5, 3. Coordinates of point D are 1, 1, 1. So R bar will be B minus D. So 8 minus 1, 7i. 5 minus 1, 4j. Plus 3 minus 1, 2k. So moment of the resultant about the ijk 7, 4, 2. That is R bar coefficients. And force coefficient 3.535, 6.363, and 2.83. Use calculator. You get the moment of the resultant about D. That is minus 1.414i. Minus 12.74j plus 30.4k. Now the third part of the problem, what it says, magnitude of the component or magnitude of the component of the resultant along the line BK where coordinates of point K are 5, 8. Again, student, I have drawn a diagram. B point has coordinate 8, 5, 3. I've just marked the resultant something like this, and I have shown the line BK. B point coordinates are given. K is given 5, 8, 3. So component of R bar along BK will be R dot BK. mod of divided by mod of bk. As we understand it, component of a bar along b bar is equal to a dot b divided by mod of b. So here you are looking for component of r bar along bk. So it will be in the numerator dot product of the two r bar dot bk bar, right, divided by mod of bk. R bar is already with us. We need to write vector bk. Bk will be what? K minus b. 5 minus 8, 3i. 8 minus 5 plus 3j. 3 minus 3, 0. So vector bk is minus 3i plus 3j. So mod of bk, square root of 3 square plus 3 square, that is under root 18. So component of r bar along bk is r bar dot here, okay, and dot bk divided by mod of bk. So you get 2. Would you get it? So it is in the numerator, it is dot product. So it will answer will come in scalar form only. All right. If you want to find in vectorial form, you can multiply it by unit vector along bk. So component of r bar along bk can be obtained in vectorial form by multiplying this magnitude with unit vector along bk. So this is a good problem covering 3 concepts of this chapter. Yes, is covering the concept. 3 concepts are what? How to write the force in vectorial form, right? How to find the moment of force about a point. Also resultant of concurrent force system. Also component of force in the some other direction. So 3-4 concepts are covered in this chapter. So it's a good problem. All right, we come to the next problem. Now this problem is based on, now we are taking next 2-3 problems will be, last problem also as involving one of the parts was resultant of concurrent force system. Now next 3 problems I'll be discussing purely which are on resultant of concurrent force system, because now the basic fundamentals we have learned it, how to write the force in vector form, you know how to find the moment of the force about a point, you know how to find the component of the force in some other given direction. Now let's start. Question number 7. I read the sum. 3 forces F1, F2, F3 act at the origin of the Cartesian coordinate system axis system. The force F1 is 70 Newton acts along OA. Force F2 is equal to 80 Newton acts along OB. Force F3 is equal to 100 Newton acts along OC. Coordinates of the points A, B, and C are 2, 1, 3, minus 1, 2, 0, 4, minus 1, 5 respectively. Find the resultant of this force system. Well, students, I have shown again this is a working diagram. It has not been drawn as per the sign convention of space force system. Any diagram, if you are drawing it properly, first you need to show x, y, and z axis. Then only diagram has to be drawn. But this type of the working diagrams are allowed in the examination because you are not writing coordinates. All right. So there is no need to show x, y, and z axis. You can simply show the point O having coordinates 0, 0, 0, origin. Force F1 is acting from O towards A, right? Coordinates of point A should be marked. F1 is 70 Newton. F2 is 80 Newton. It is acting towards B, having coordinates minus 1, 2, 0. Then F3 is acting towards C, having coordinates 4, minus 1, 5. Now, you have to find the resultant of this concurrent force system. So what I'll have to do, I have to write all the 3 forces in vectorial form. I have to write all the 3 forces in vectorial form, and resultant of all the force system will be add all the forces in vectorial form only. So let's start. So since 3 forces F1, F2, F3 are concurrent at O, the resultant will also pass through O. And what will be resultant in vectorial form? F1 bar plus F2 bar plus F3 bar. Now what is F1 bar? It is equal to 70 into lambda OA, right? 70 lambda is A minus O. O is the origin only. So whatever the coordinates of point A are there, that will become the vector OA. So 2i plus 1j plus 3k divided by mod of 2 square plus 1 square plus 3, you get the force in vector. F2 bar will be 80 into lambda OB. Lambda OB will be B minus O minus 1 minus 0 minus 1i. 2 minus 0 plus 2j. And 0 minus 0, 0. So it comes out to be minus 1i plus 2j. Divided by its mod, you get F2. F3 bar, how to come it arrives? F3 bar is 100 into lambda OC. All right. Lambda OC is what? Vector OC divided by mod of OC. Vector OC is what? 4 minus 0, 4i minus 1j plus 5k divided by its mod. You will get it. Force in vector. R bar at O, F1 bar plus F2 bar, F3 bar. When you add up F1 bar plus F2 bar, F3 bar, F1, F2, F3 are ready in vector form. When you add them up, ij coefficients will be added up. So finally, you get the resultant in vector form like this. If you want to find the magnitude of resultant as it is required in the sum, square root of fx square plus fy square plus fz square. So you get the resultant. You want to find the three angles, what the resultant is making with x, y, and z axis. Cos theta z axis, fx upon f. Substitute the value of fx, substitute the value of f. You get theta x by taking cos inverse. Cos theta y is fy upon f. All right. Cos theta z is fz upon f. Substitute the value fz and substitute the value f. All fx, fy, fz, all three were positive. If any of the components negative, you have to substitute negative only in these calculations. So this way, we found magnitude resultant and we found the angle what the resultant is making with x, y, and z axis. Let's move to the next sum. In this problem, we have is also again identical type of the problems, but this time the it's a question has been asked in a little different manner. So we'll understand it what exactly it is. All right. This is also a problem on resultant of concurrent force system. I read the sum. A pole is held in place by three cables. If the force of each cable acting on the pole is as shown in the figure, determine their resultant. Now you can see that there is a pole, right? Pole is anchored by or positioned by three cables connected to its top point at D. Now one cable is connected to point A, another cable is connected to point B. That is, we can call it as first cable, we can call it as DA, another is DB, another third one is DC. Coordinates of point, all the points are given in the diagram, right? Coordinates of point D is given, A is given, B is given, C is given. Magnitude of the three forces are given. All the three forces are acting at D, away from D, towards first force is acting towards A, another is towards B, and third one is towards C. Now you have to write all the three forces in vector form. As the three forces are concurrent at D, the resultant will also pass through. Let's write the force F1. We call force 600 Newton as F1. As its name is not given, F1 we call it as 600 Newton, which is acting from D towards A. All right, D point coordinates 0, 0, 24, and towards A minus 18, minus 16, 0. These are all given in the problem. We call F2 force as 400 Newton, which is acting from point D towards B. D point coordinates are 0, 0, 24, and B point 15, minus 20, 0. Then third force is 800 Newton, that is F3. It is acting from D towards C. D point coordinates 0, 0, 24, C point coordinate 4, 0, 0. Now we need to write all the forces in vector form. How we write force F1 bar? 600 into lambda dA. dA means what? A minus D. Minus 18 minus 0 minus 18I. Minus 16 minus 0 minus 16J. 0 minus 24 minus 24K. Divide by its mod, you get the force in vector. Then second one, F2 bar is equal to 400 into lambda dB. Slight error is there. It is not AB, it is lambda dB. It is lambda dB. But working wise, it is perfect. What will take lambda dB means what? Vector dB divided by mod of dB. So B minus B. 15 minus 0, 15I. Minus 20 minus 0, minus 20J. 0 minus 24, minus 24. Divide by its mod, you get force in vector form. Third is 800 into lambda DC. Lambda DC means C minus D will have to take it. 800 into C minus D. 4 minus 0, 4I. 6 minus 0, 6J. 0 minus 24, minus 24 divided by mod. So you got F3 in vector form. Then R bar at D will be equal to F1 bar plus F2 bar plus F3 bar. So your resultant is ready in the vector form. To find the magnitude as in the last sum, square root of Fx square plus Fy square plus Fz square. In fact, all the three components are negative, but when you are taking square, we don't need to write negative sign. So you got the resultant in magnitude. Now, theta is x. Now we will find the three angles, what the resultant is making with x, y, and z axis. Theta x is cos inverse of Fx upon f. Fx is minus 16.82. And this is your resultant. You got theta. Theta y is cos inverse of Fy minus 32.321.65 upon f. You got theta y. Theta z is cos inverse of Fz minus 1466.68 divided by r. You get it, theta. So this problem was also identical to the previous problem only. All right. Only thing is this time all the forces were acting at point D, which has some coordinate which is lying on y-axis, but all the coordinates were given. So there was no much difference in the previous sum and this sum. But since the type is important, that's why I have taken two problems. In fact, in my book, you'll find even one or two more problems given on the same concept. Now, little application now in the next sum. Okay. This time resultant is given and components are required. What is the difference in this sum from the previous 2-3 sums? This time resultant is given and components are required. I read the sum. The resultant of three concurrent space forces at A is R bar is equal to minus 788 J. That means resultant of the three concurrent forces at A is minus 788 J. That means the resultant doesn't have X and Z component. It has only Y component, that is minus 780. Find the magnitude of F1, F2, F3. If I look at this diagram, students, A point is lying on Y axis. This is force F1 is acting from A towards B. F2 is acting from A towards C. F3 is acting from A towards C. Now we need to write the coordinates of various points, right? We understand that three forces are concurrent at A. So we'll write them in vector. Coordinates of point A as it is lying on Y axis, so we'll have only Y coordinate 0, 12, 0. Point B is lying on X axis on negative side, so we'll have only negative X coordinate minus 9, 0, 0. Point C is lying on Z axis, so we'll have only, but it is on positive side, it will have only Z coordinate. What is that? 0, 0, 5. Point D is having XZ plane, right? The coordinate parallel to X axis is 3 meter on positive side. Y is 0 since it's lying in XZ plane. Z coordinate is negative since coordinate parallel to Z axis is being measured from origin on negative side. So it's going to be 3, 0, minus 0. This way we have written coordinates of all the points A, B, C, and D. Now you can easily write the force in vectorial form. F1 bar is equal to F1 into lambda A. AB means what? B minus A. So coordinates are here B minus A, minus 9, minus 0, minus 9I, 0, minus 12, minus 12J, 0, minus 0, minus 9I, minus 0. Divide by its mod, you get force in vectorial form. F2. F2 bar is equal to F2 is magnitude into lambda AC. AC means what? C minus A. So 0 minus 0, 0I. 0 minus 12 minus 12J. 5 minus 0 plus 5K. Minus 12J plus 5K divided by its mod, you get force F2 in vectorial form. Then F3. F3 is what? F3 bar is F3 into lambda AD. AD means what? D minus A. So D minus A is 3 minus 0, 3I, 0 minus 12 minus 12J, minus 4 minus 0 minus 4K. Divide by its mod, you get the force in vector. So R bar is F1 bar plus F2 bar plus F3 bar is given to us minus 788. I'll substitute the value of F1 bar, F2 bar, F3 bar from here. Here F1 is magnitude of force F1, F2 is the magnitude of force F2, F3 is magnitude of force F3. We have written them in vectorial form. So IJK coefficients are along equal to 0I minus 788J plus 0K because resultant is having only Y component. X and Z components are 0. Now IJK coefficients will be equated from the equated from both sides. I coefficient will be minus 0.6 F1 plus 0.23 F3 equals 0. J coefficient minus 0.8 F1 minus 0.923 F2 minus 0.923 F3 equals to minus 788. So all terms are negative. Yeah. K coefficient plus 0.385 F2 minus 0.308 F3 equals 0. Solving equation number 1, 2, 3, you get the value of F1, F2, and F3. Solving equation number, these are three simultaneous equations. Solving three equations, you get F1, F2, and F3. So this problem also the steps are same. Only the difference what has come in this problem, instead of finding the resultant or asking the resultant was given and components were. Now we will understand another type of the problems which are remaining is that how to find the moment of the force about an axis. How to find moment of the force about an axis or about a line. Let's see the sum. A force of magnitude 20 kilonewton acts at a point A having coordinate 3, 4, 5 meter has its line of action passing through point B. That means 2 points on the line of action of the force are given. Coordinates of the 2 points on the line of action of the force are given. Magnitude of force is also given. Calculate the moment of this force about the line passing through point S and T. S and T coordinates are also given. So students, we understood in the beginning of the lecture how to find the moment of the force about a line. Now, again, we have drawn a working diagram. In this working diagram, first I have shown my force, called it as F is equal to 20 kg. I have shown it is acting at A and this line of action passing through. That means it is acting from A towards B. Coordinates of point A 3, 4, 5. Coordinates of point B 5, -3, 4. You want to find the moment of this force along the line ST, right? We have drawn a line, that's ST. Anywhere, that's it appears that both the force and the line are in a plane, but they are not in a plane. This is a working diagram. Coordinates of point S 2, -5, 3. Coordinates of point T -3, 4, and 6. Now, first we write force in vectorial form. What is that? 20 into lambda AB. 20 into lambda AB means what? First, vector AB divided by its small. Vector AB is B minus A. 5 minus 3 to I, -3 -4 -7 I, 4 -5 -1 K. Divide by its small, you get the force in vector form. Now, you have to also find the unit vector along the line. Unit vector along the line is lambda ST. Lambda ST is what? Vector ST divided by mod of ST. ST is T minus S. -3 -2 -5I. 4 -5. That is 9J. 6 -3 plus 3K. Divide by its mod, you get unit vector along the line. We know that moment of the force about ST. I'll write here, moment of the force F about line ST is equal to unit vector along the line ST dot moment of the force F about the first point of the line. So first unit vector along the line is ready. Now you will find moment of the force about the first point on the line. So moment of force about S is equal to R bar cross F bar. F bar is ready in the vector form. R bar will be what? What is going to be R bar? Position vector of any point on the line of action of the force with respect to moment center. What is my moment center? S. So you can take position vector of A with respect to S, or we can take position vector of B with respect to S. Friends, we need to understand here, position vectors may be different, but final answer, moment of the force F about S will come out to be same. So this is a fundamental property of the vector. So right now we have taken position vector of A with respect to S. So that is A minus S. 3 minus 2, 1I. 4 minus -5, that is 9J. 5 minus 3, 2K. Then you find moment of force about S. First row IJK, second row are components of position vector 1, 9, 2. Then these are the three components of the force Fx, Fy, Fz. From here we have substituted. Fx is 5.443, Fj is -19.054, Fz is -2.72. You got the force, moment of the force about first point of the line. Then moment of the force about St. It will be always in scalar form. Lambda St dot moment of force about S. Lambda St we have substituted from here. Moment of force about S we have substituted here. We are taking dot product, so it answer comes in scalar form. So this is moment of the force about line St. But if they do not say anything, you should not leave the answer in scalar form. You should write the answer in vector form. Moment of force about St in vector form, it is magnitude into lambda St. Magnitude -13.922. Lambda St is substituted from here. Then you get the moment of the force about St in vector form. So this is your answer. All right. So hope you have understood how to find moment of the force about it. Now we come to the last problem of this type, that is type 1. Another problem of the moment of the force about a line or about an axis. I read the sum. The rectangular platform OCD is in the diagram it is shown, is hinged to the vertical wall at A and B, that is shown in the diagram, supported by a cable which passes over a smooth hook at F. It is passing through the smooth hook F, that is indicative that tension in the cable on the two sides will be same. If the cable is passing through hook, all right, passes over the hook, that means tension the cable on the two sides will be same. Tension the cable is given to as 355 Newton. Find the moment about each of the coordinate axes of the force exerted by the cable at A. That means I have to take the tension in the cable at point D, and tension is always away. So tension, direction of the tension, what we need to consider at point D will be away from B. Now, friends, I have drawn the diagram. In this diagram, same diagram, but little simplified version, we have drawn it. This dimension is 2.25. This dimension of the platform is 3.2 meter. We have to take tension in the cable at point D as he has suggested. So tension in the cable at point D is just away from D towards F. We need to write the coordinates of points. He is asking you to find the moment of the tension in the cable about the three axes OX, OY, and OZ. So coordinates of origin will be obviously 0, 0, 0. Now coordinates of point F. Point F is lying in XY plane. So that means Z coordinate will be 0. X coordinate will be 0.9. Y coordinate is 1.5. Z coordinate is 0. So coordinates of point F are 0.9, 1.5, and 0. Let's come to point D. Point D is lying in XZ plane. Point D is lying in XZ plane. X coordinate parallel to X axis 3.2 on positive side. Y coordinate is 0. Z coordinate parallel to Z axis is 2.25. So you got the coordinates of point D also. Now you need to write tension in the cable in vectorial form. So tension T bar is equal to 355 into lambda dF. dF means what? F minus T. Magnitude into first vector dF divided by small. dF means what? F minus T. 0.9 minus 3.2 minus 2.3 I. 1.5 minus 0, 1.5 J. 0 minus 2.25 minus 2.25 K. Now, using your calculator, you get tension in vectorial form as minus 230I plus 150J minus 225K. Now you want to find moment of this tension about OX, OY, OZ. So what is the common point on the three axes? That is O. So first we should find moment of this tension in the cable about point O. That is R bar cross T bar. T bar is already with me. R bar is position vector of point D with respect to O. Or we can take a position vector F also with respect to O. But we have decided to take both. See, position vectors will be different. Position vector D with respect to O and position vector F with respect to O will be different. But when you take the moment, they come out. It comes out to be same. Anyway, right now we are taking position vector D with respect to O. So D minus O. 3.2 minus 0, 3.2 I. 0 minus 0, 0 J. 2.25 minus 0, 2.25 K. Now moment of T about O. I, J, K. These are the position vector coefficients. 3.20, 2.25, and tension in vectorial form minus 230 plus 150 and minus 225. On using calculator, you get it moment of D about O, but that is minus 337.5 I plus 202.5 J plus 480 K. Now you want to find moment of T about OX. That is going to be dot product of unit vector along the line. That is lambda OX dot moment of T about. But you know that unit vector along the line OX or along axis OX is I dot. You write moment of T about O. Here only I coefficient will be effective. So moment of T about OX is minus 337.5 Newton meter. But this is again a scalar form. But you want to find finding the moment about OX axis. So unit vector along OX should be multiplied if you are writing the answer in vector form. So in the bracket, I have written the answer minus 337.5 I. And here units are also written. So this is the answer moment of T about OX in scalar form. This is the answer in vector form. Same way, moment of T about OY is lambda OY dot and moment of T about 2. You write lambda OY J and you write dot this. Then you here J coefficient will be effective. So moment T about OY is plus 202.5 Newton meter. And the vector form plus 202.5 J Newton meter. Then moment of T about OZ is lambda OZ dot moment T about O. Lambda OZ is K dot moment T about O. Just substitute, you get K coefficient, that is plus 480 Newton meter. Or in the vectorial form plus 480 K as unit vector along Z axis is K. So this way we have covered the problems of type 1 in space force system. This is my 5th chapter on statics, what videos I have uploaded. All right. For this chapter, we are left out with type 2 problems resultant of parallel and resultant of general force system. In total, 11 problems I have covered from type 1 of this chapter, that is resultant of concurrent force system, including basic concepts. So they ask many times the problems on basic concepts only. They may not ask the problem resultant, but you have to understand each and every type of the sum. Many more problems are given which are solved in my book. Apart from 11, there will be find 5-7 more solved problems in my book. All right, and even multiple choice questions, right, unsolved problems for practice are also given. All right, this video lectures are free to all. All right, there are no charges. You can pass on the QR code of my YouTube channel to to your friends so that they are also benefit. You are also requested to subscribe to my video YouTube channel so that you will get the notification as and when I'm uploading the new video lecture. So please be informed about it. All right, my book, if you want to buy the book is available on Amazon as well as in local bookstores. The link of Amazon is given in the video description of every video lecture. All right, my next lecture is going to be covering type 2 and type 3 of resultant of forces in space. Thank you.